This is my $75 eBay Tandy 1000, and it looks great after 5 days of sun brighting, but it remains completely devoid of any sign of life. Can we raise it from the dead in time for Halloween? Stick around, because we're going to find out right now in episode 46 of Retro Bits. Happy October, everybody. Yeah, I didn't plan on this project spilling over either, but things didn't go well with this machine last time, so here we are. Speaking of which, if you haven't seen part 1, I suggest you start there first, link in the description, as we'll be picking right up where we left off. Previously, we attempted to diagnose a faulty power supply, tried sun brighting for the first time with outstanding results, and discovered that our clean-looking keyboard from eBay was anything but on the inside. So today, let's see if we can recover from these setbacks in RetroBit's first ever two-parter. Right, let's get to it. When we last left this Tandy 1000, we had just discovered an unpleasant surprise lurking inside what appeared to be a very nice keyboard. Boy, is that disgusting. And disappointing. At this point, I really don't know if this thing can be saved, which is a bummer because these keyboards are pretty rare and often cost as much or more than the computer itself. So, the nasty plastics went into the tub for a nice long soak and a scrub down, so now we need to deal with the corrosion on this PCB. I've never done this before, but given the state of the thing, there's really not much to lose if it goes horribly wrong. I'm hoping this will cut through the grime, rust, and peeling pieces of solder mask so we can see what's left and take it from there. I'm placing the boards on the top rack with the sensitive parts facing away from the jets, using a low temperature setting and disabling the heated dry cycle. Alright, the wash is done and it's time to see what's left of the circuit board. Not bad. This piece is still intact, and the chunks of rust and accumulated grime aren't falling off everywhere now. Some surface corrosion is still present, but it's already looking a whole lot better. The PCB is looking a whole lot cleaner too, even though the damaged area is still ugly. The solder mask is completely gone here, but that's okay, we'll deal with it later. What I was most afraid of was that the leaf spring switches would break off in the wash, but fortunately none of them appear to be missing, which is a huge relief. I accidentally pulled off the one switch in the top row earlier during disassembly, and I have the part stashed away with the keycaps for later. Next, I'm going to use some compressed air to remove as much of the water as I can that's hiding inside and under each of the components on the board. Some of the stubborn gunk didn't even come off in the dishwasher, so I'll have to tackle it with some good old-fashioned elbow grease. Afterwards, this part will get a rinse and blow dry as well. Despite a trip through the dishwasher, some of the switches still show a significant amount of copper oxidation on the inside surface. These are third-generation Fujitsu leaf spring switches, and they're long out of production, so I can't just buy replacements and swap out the bad ones. Worse, the internal mechanism isn't serviceable, as the spring is retained by plastic tabs that are melted in place. Under the spring is a clear plastic sheath, and under that is a small dome-shaped disc. When the leaf spring presses on the disc, it deforms enough to contact terminals beneath and close the circuit. Despite the visible oxidation, I did verify continuity using my meter, and the switches still work, so I'm hopeful that I don't have to break the tabs and go in there to perform further cleaning. If I can get the machine to power on, I'll connect up the bare PCB and attempt further testing then. While we're taking care of the small items, let's not forget to glue the broken plastic tab back on. Last, but not least, I dropped a number of rusty screws into some white vinegar and left them to soak for a bit. Check it out, you can see the oxidation just coming away in chunks. After a quick rinse, you could barely tell these were completely rusted and disgusting before. Nice. Time to recap. Yes, that kind. Here's my list, and here's my box of parts. Once again, courtesy of Console5.com. I've already opened the package to verify its contents. I figure, since the power supply is completely dead, and I've already performed the diagnostics I can with the tools I have, this is the least expensive next step. Time to break out my new desoldering gun again. As I've already inventoried all the caps and the PCB silkscreen is properly labeled, I'm going to do something I haven't done before and remove all the parts at once, and then solder all the replacements in a single go. Should be fine, right? Easy peasy. Again, I don't know why I didn't get a desoldering tool sooner. As always, reassembly is just the reverse. In the last episode, we discovered that there was some sketchy looking solder joints at the motherboard connector, so I'm going to reflow each of them. And there we go, all done. Don't worry, I'll be sure to clean up all that nasty old flux residue. Last time, we measured no voltage on any of the output pins whatsoever. I'm really hoping that we get something this time, because if not, I'm out of ideas. Huh, that's something. I definitely saw 5 volts on the disk drive Molex connector, but then it dropped off. Better than nothing at all like before though. Let me try on the motherboard harness. Same result. Perhaps there's some protection circuit that shuts things down when there's no load? I'm not well versed in power supply design, but there was definitely 5 volts for a moment. I could simulate a load on the supply and retest, but you know what? Let's just friggin' send it. I've reinstalled the power supply and connected everything up. Let's see what happens this time. Something isn't right here, but the fact that the speaker is getting power and sounding out an error is promising. I racked my brain thinking of what I could be missing. Clearly the machine is getting power now, but it's not happy. I double-checked all the connections. Could the board itself be faulty? Maybe the damaged isoslot. What could it possibly be? Ah yes, we're not going to get very far without this. The legs in this smartwatch are in pretty bad shape, so I'm going to try and straighten them and then reinstall the whole package. In addition to being bent, some of the legs are twisted pretty badly as well. I'm afraid they're going to break off in the socket, so I'll just extract the BIOS chip from the battery. It's probably dead at this point anyway. There we go. Let's try powering on the machine again. Heck yeah! Would you look at that? Finally, something's going right with this machine. Awesome. Just for fun, let me introduce you to Plan B. This is a Tandy 1000 SX power supply that I got on eBay in tested working condition for $15. It supplies the same voltages as my supply, but has a different pinout. In addition, it uses an integrated DC fan versus the external AC fan on my system. The chassis is larger, so it's not a direct fit, but I was hoping I could modify the sheet metal or transplant the PCB into the original housing. And for good measure, here's Plan C. This Meanwell power supply provides both the correct voltages and amperage, plus it should fit right inside the machine's original housing. It's quite affordable as well. I picked up this tip from a member of the VCF forum. Okay, I can't wait. The machine boots, so now I want to see if either of the add-on cards survive shipping. First, I'll install the RAM expansion in one of the undamaged isoslots. Score! This is a pretty nice piece of kit to have, and it seems to be working fine. The machine does take a fair bit longer to boot up with the extra RAM, but that's par for the course. Next up is the hard card. If you remember, this was found to have been bouncing all around inside the machine during shipping and caused the damage to the isoslot and smartwatch chip. I'm not going to hold my breath on this one. Well, the LED on the card is flashing, but the disc itself isn't spinning up at all. It's probably an error code, not activity. Honestly, I didn't expect this to work. Even under the best of circumstances, these mini-scribe discs expire from old age, never mind ones that have been banged around in shipping. The controller card itself may still be good though. Well, that's a huge relief. It just goes to show that old caps can look perfectly fine on the outside, but still be the cause of a complete and total failure. For $13, replacing them was well worth trying first, and in this case it paid off and I couldn't be happier. Since we now have a machine that boots, let's take a deep breath, connect the keyboard PCB, and attempt to determine just how badly damaged it is after all that corrosion and subsequent trip through the dishwasher. Right away, the machine started beeping non-stop, a telltale sign of a stuck key and a full keyboard buffer. Still, signs of life. With a little trial and error, I narrowed it down to one of the corroded switches and had no choice but to break the plastic tabs in order to clean the internal parts. With the problem switches cleaned, it's time for a retest, and there's good news here. Most of the switches are working, so fundamentally the keyboard is good. Let me test the numeric keypad as well. This is where the bulk of the damage to the solder mask, ground plane, and traces is found, yet the affected switches all seem to be working. Honestly, I can't believe it. It just doesn't seem possible. Well, in for a penny, in for a pound. If I don't clean these now, they'll likely cause problems in the future, and I'd rather not take the whole thing apart again if I don't have to. And there we go. 11 switches in total required cleaning, plus the one I broke by accident earlier. Looking at the amount of gunk that came off, I'm pretty confident that this was the right decision. Now that everything is clean, it's time to attempt reassembly. The discs go in first, then the clear membrane, and then the leaf spring. I found that with the plastic tabs now broken, there's nothing to hold the pieces in place. I kept dislocating the ones I had already placed while trying to install the next. My hope is that when I put the keystem assembly back on top, it'll hold everything down in the right place and they won't be able to move about. Of course, getting each of the keystems to line up perfectly without knocking anything out of place is going to be a challenge. I'm using the caps and numlock LEDs as guide pins before dropping the board into place. Fail. Most of the switches are good, but at least 2 didn't line up properly. And now, I have to start all over again. Step 1. Place each of the membranes and switches again. Step 2. Place the keystem assembly over the switches. Step 3. Knock something out of place. Step 4. Go back to step 1. Ugh, this process is absolutely hateful, and I never want to do this again. After 6 attempts over what felt like several hours, my back was killing me, but I had also come tantalizingly close to success. Everything was seated correctly except for 2 switches. It was then that I discovered a simple trick that doctors hate. The broken keystem taught me that each individual part could be easily removed just by depressing the tabs on the side. Removing one stem allowed me to fix a single switch without affecting any of the others or having to reseat the entire board. Now we're getting somewhere. Each key appears to be working, mechanically at least. Time to plug it back in and test our repairs. Well, it didn't work, and a little more head scratching revealed why. The tabs that used to hold the spring in place would prevent it from torquing. Without them, the plunger presses the spring, and the spring rotates instead of pressing firmly down on the disc. So, everything up till this point was a learning experience, and I'm going to have to do what I should have done in the first place. I'm hoping that superglue will be sufficient to secure the metal spring back to what remains of the plastic tabs. Ideally, I'd just sourced some replacement switches, but I was unable to find any for sale. They're found in a number of other keyboards, but these are all hard to find and in some cases more expensive than the Tandy keyboard itself. And there we go. They seem to be holding in place, so let's get this thing buttoned up for the last time. I'm happy with the work on the front side of the board, so now it's time to turn our attention to the back. I'll use a fiberglass pencil to remove what's left of the old solder mask and corrosion from the damaged traces and ground plane. Next, I'll apply a UV curing solder mask to the traces to prevent further oxidation and corrosion. I normally use this for indoor retrogriding, but it works great for this purpose as well. Nearing the home stretch now, so let's not forget the small details. The cord is gross from stem to stern, and it wouldn't be right to clean everything else and not this as well. And there we go. Much better. Now all that's left is a reassembly montage, so here it is. Well, that took many hours longer than expected. So we're going to have to put off repairing the ISA slot, installing the XT IDE card, and putting the machine through its paces until next time. Did I say first ever two-parter? Clearly I meant 3. Despite spending the entire weekend repairing a $60 keyboard, I'm absolutely delighted and more than a little surprised that it works at all, never mind at 100%. Absolutely crazy, given all the corrosion damage it suffered. Going in, I really expected to have to jumper a dozen ruined traces, but unbelievably they were all fine. Instead, the non-serviceable key switches were the real challenge. Anyway, I'm stoked we were able to bring both the system and the keyboard back from beyond the grave with relatively simple repairs. And we got to learn all about Fujitsu leaf spring switches too. I hope you enjoyed this bit. Thank you so much for watching. Thanks to all my awesome patrons. Push some buttons, leave a comment, and we'll see you next time on Retro Bits.